Voila. So I built a Streamlit app that takes our natural language prompt or question and lets us visualize our data in our data set. So here I have a CSV file that I already uploaded, and it's about different car prices based on brand and mileage, etc., etc. So the point is, here's an app built with Streamlit that lets us visualize our data. So let me show you one more. So we can say, show me the average car price by I'll come back and do some other queries or prompts here to really show you the power of this app here. So before I get going and I show you how I did this and how you can do this, hey, please like this video and subscribe to my channel if and only if you find the remainder of the video useful, helpful, and or interesting. Thank you. And also, as always, in the description I will leave a link to my code and anything else I'll show you in this video. Okay, so how did we do this? So essentially 3 steps I want to walk you through. The first thing is obviously get the user's prompt, for example, what they want to visualize. Then what I'm doing in this app is taking that prompt and the metadata of our data set. The metadata is basically telling us what the field names are, column names are, what type of what type of data it is, etc. So we take the prompt and the metadata of our data set, and in this case I'm using Gemini 2.5 Flash from Google. So I sent all that to the large language model, and I'm asking for it to give me a Python code based on the prompt and the metadata. And so it returns a Python code that will provide the visualization based on the prompt. And then final step is that we take the Python code we got from Gemini 2.5 and we run it with a built-in Python function to execute that code that we got from Google Gemini, and that's what generates and displays the chart. All right, so that's how this was created. I've done a video about a year ago, I think, showing you something very similar, actually very similar, using Pandas AI, where you can get an API key, a free API key, and lets you do, I think, 100 free queries a month. But this is, and I showed you in that video, and I'll leave a link to that video as well for you guys. We can visualize it using this API. But I want to show you without any API how we can do it sort of natively with Python, right? How do we take a code from Google Gemini and visualize it? So this is how we did it. And one thing about, I'll leave a link to this as well. This site does a really good job of explaining this built-in exec function, which lets you run dynamically generated Python code. In our case, it is dynamically generated from the large language model based on our prompt and the metadata that we are providing to it. Okay, so that's how it's done. It's simple as that. It's just there's 3 things. It's actually pretty mind-boggling how you can do this, locally. And one of the things I'd urge you to do is like read as much as you can about this. Definitely, a lot of these things don't come without some security issues or risks. So understand those things as well. These guys do a good job of like telling you how to use it, what are the use cases and all that, but also walks you through what security issues you might have. But in our case, it's we're running this from a local file, and we're dynamically getting a dynamically generated code from Google Gemini, which we can trust, and so really no security issues from that perspective. So let's do something more complex. So this is a data set that has 10,000 records and has all these different features. And so let me go back to the prompt here. We can say things like, hey, create 5 bins from the engine size and show me the average car price by this 5 different bins. So it basically, bin the engine size and then just shows us the average car price. And nice thing about Plotly is that you can download the plot as a PNG and all that. You can, expand this thing, shrink it back, etc. And so it's a pretty good way to visualize. And honestly, you can do anything else that you want to think about doing. I'll do one more. I want to understand if there is any correlation between the car price and the engine size. All right, so it's going to, the large language models are really good. It will take this and figure out how to best visualize the question the user has or the prompt the user has, right? So, and this is probably the best way to show any kind of a correlation. So, yeah, and then it's going to return the Pearson correlation of the price and engine size in this case. So that's how it works. Let me show you the code that I have written, and it's pretty straightforward. It's only this many lines of code. What's really one of the most important things here is the context we got to provide the large language model. So, you'll have access to my code, so you can read this for yourself. But it's, I've done my best. I'm certain. I know I'm certain that this can be further enhanced and can be even more crisp and precise. So, but in any case, this worked for me, so I'm going to stick with it. So that's the first thing. Okay, that's important. And then second is, let me just show you how this is really done. We upload the file, pretty straightforward. And then I calculate a few things here about the data set, the length of the, how many rows are there, etc. And then really creating the metadata. So what I'm interested in providing the large language model is the different column names, what the D types are, and I've found that providing things like this, non-null count, etc., unique values, just gives more context to the large language model, so they will do even a better job at writing that code for you. So once we get the code back, once we have this metadata, which is fed here, we send the prompt and the instructions to Gemini 2.5 Flash. And one of the other things I've done is that it's a thinking model, so I'm making sure I'm using the power of its thinking capabilities. And so I've allowed some budget here of 1,000 tokens. I think it's more than sufficient for something like this. And so once we get the response back, that's where we use this built-in function and provide it the response, which is really the Python code. I'm very explicit in saying, you always provide a Python code, etc. And for as much as I've used this for this particular data set and for some couple of other things I've done, it does a good job. And it comes down to the context and the instructions we provide. So if something's not working out, say first come here and see how we can tighten this to get us what we need, okay? And as always, you got to provide your API key, Gemini API key for this to work. And I think that's that. So back to the app. It is just something as simple as that, leveraging the large language model to give us the code that will help us visualize our own data. Okay. Now, in my case, this is a data set I downloaded from Kaggle. It's freely available. It has the naming, the column names, the feature names are self-explanatory, right? Sometimes you might not have that. Then it's crucial that you, let's say in this case, it was named like XO, X1, X2. Then we should provide a description, says, hey, this field is the brand name of the car, etc., etc. And in my code, I'm already showing you how to create the the metadata. So you could probably just write a one-off code, create yourself this metadata, and in that JSON file, come back and just add the description. And then in my code here, if that's what you need to do, where you're going to provide your own custom metadata, you would just, here I commented it out, but you can just use something like this to load that JSON, and you call it metadata, and so it's just going to use that custom JSON in your case, if that's what you want to do. So that's how you can take care of it. Here's another thing I did comment out, but if you want to use it, you can. So let's say you're like, you know what, that's great, I put in my prompt, I get to see the visualization. I'd like to see what code it ran, or it constructed and executed, right? So just uncomment these three guys here, okay? And that should uncomment this guy's, all three, and then you'll need to comment this guy, okay? So uncomment this three, and then comment this. So in that case, what it's going to do is it's going to show a button and run the code, and when you click that, it will just run this guy, or you will use this built-in function, and because we're setting up this Streamlit code capability. So instead of just showing you the text, it's actually going to show you the code as a Python code. So you can visualize the code with this line, and then you would run the code to actually see the visualization. So hope this you found this to be helpful and useful. And another way to use Streamlit along with a large language model to actually practically accomplish something that we normally want to do is visualize our data. You can build this for your colleague or your team members who are not proficient with writing codes, etc., or you can use it for yourself. Plenty of different ways to do it. A couple of things you could probably take this even further with. One is, try using more than one table or one data set. In that case, you want to accept multiple files, and then you probably would have to somehow tweak the code so that you're sending two different data frames, and you'd want to explain all of that stuff in your instructions, and how to join those two tables or those two data frames if that's required, how the model would need to do that, etc. Okay, so that's one use case. The other one is, in my case, I kept it incredibly simple. Provide a prompt, and you get the visualization. I can put in another prompt, I'll get another visualization. So the second thing you could do is take this even further by making this a conversational chatbot. So you could do it in a way so that you can do some follow-up. Say, oh, you know what? How about I show me that I don't like the color blue. I want to see it. Use the color red or whatever, right? So you can, So there are ways to take this even further, but hopefully gives you enough that shows you how to use this built-in function, a large language model, to visualize data. Until next time.